Hello and welcome to Aditya classes, where today we'll be talking about how to solve a linear problem graphically. Now in past also we have taken certain questions where we have tried to solve linear problems using graphical method. Now this is a question that was requested by one of our learners on the channel. So today we'll see how we can solve this graphically. So I'll put up the question over here and then we'll take up the equations and solve it. So the question goes z max is equal to 10x plus 6y. Z max is equal to 10x plus 6y. Subject to certain constraints, the constraints are subject to certain constraints being 7x plus 3y less than equal to 100. So our first constraint is of type less than, then there is 4x plus 6y. 4x plus 6y less than equal to 80. Then there is last constraint which is a little bit different from what we might have talked of or discussed in past, which says y greater than equal to 2x. So when we have a look at these three constraints, we see that we have first constraint which is of type less than, straightforward constraint. Second constraint which is of type less than, again a straightforward constraint. Third constraint is a bit unconventional because we have variables scattered on both sides of inequality. If the variables are on one side, numerical values are on the other side, we can solve it easily. But in this case we get stuck that the variables are on both sides. What should I do? So what we'll do is, first we'll try to understand what this constraint is all about. It looks different. So when we look at this constraint, we'll pull it out and then we'll see what this constraint is all about. This constraint is y greater than equal to 2x. Now there can be two treatments for this constraint. Let us have one treatment in different color. One treatment could be that you could bring in this 2x on the left hand side. In that case, what we'll do is 2x coming onto left hand side would make it minus 2x, positive becoming negative when switching the sides. This will stay plus y, sign remains greater than equal to, and here we are left with the 0. One alternative is this, that you bring the 2x on LHS. The other alternative could have been that you take the y to the other side. In that case, it becomes 0 because y is going on that side. This remains in same state. And here what I get is 2x. This y is coming on this side, so it will become minus y. Now, we do not have a practice to deal with the variables on right hand side. So what I'll do is, I'll flip this equation completely. What is this equation? This equation is 2x minus y is less than 0. If we read it out, it is that 2x minus y is less than 0 or 0 is greater than 2x minus y. I'll flip this equation to bring the RHS to LHS, making it 2x minus y. This thing should be less than, so I'm making it less than 0. So two treatments of this kind of constraint could be either we could make it, convert it into this constraint, or we could convert it into this constraint. This is first thing. Then how do we solve these? Simple. What is our method? We try to find out 2 points, first point and second point. If I get 2 points, I can plot a line. This you can check out in our previous videos. Same I'll try to do with this one, x and y, first point and second point. Now remember, I am not solving this question 2 times, rather I am taking 2 possible solutions of this, 2 possible approaches rather, not solutions, 2 possible approaches. You could go with this approach or you could go with this approach, you will get the same result. Now how do we solve this? I put x is equal to 0, that is the idea. We put x is equal to 0, find out value of y, then we put y is equal to 0 and find out value of x. This is the idea that we use. So if I put x is equal to 0, this all is gone and we get y is equal to 0. So one point becomes x is equal to 0, making y is equal to 0. Next time when you try, you put y is equal to 0. You get minus 2x is equal to 0, x is equal to 0 upon minus 2, giving me x is equal to 0. So when I put x is equal to 0, I get y is equal to 0. When I put y is equal to 0, I get x is equal to 0. Now this again is a problem. Both points are coming as 0, 0. This was 0, 0. When I put x is 0, y is 0. When I put y is 0, x becomes 0. This is a conflicting state. I am getting same point. First point is also 0, 0. Second point is also 0, 0. How will I plot a line? In order to plot a line, what we need is, in order to plot a line, I need 2 points. If I have 2 points, I can plot a line. If I have 2 points, I can plot a line. But if I get only 1 point, first time I get second point as the same point. How do I plot a line? Will this be my line? This will be my line. Any of these can be my lines. So in order to plot a line, in order to be able to plot a line, what we need is, we need 2 distinct points, 2 different points. These two are same. Putting x 0, y becomes 0. Putting y 0, x becomes 0. So 0, 0, 0, 0. How do I proceed? What we'll do is, we'll give x any possible value. Not too large, but within manageable limits. Let us say I gave x as, you could give any value. Let's say I give x as 10. If I give x as 10, what does this equation come down to? Minus 2 into 10 plus y is equal to 0, making it minus 20 plus y is equal to 0, making it y is equal to 20. So if I put x is equal to 10, I get y is equal to 20. So I've got my 2 points. I needed 2 points, now I have my 2 points. I can plot a line. Fine. What about this case? In this case, we see, if I put x is equal to 0, minus y is equal to 0, or in other words, y is equal to 0. Same case. Second time, if I put y is equal to 0, x will become 0. So again, we are in this kind of dilemma. What I'll do is, let me put x is equal to, y is equal to, let's say, 10. Let us say I put y is equal to 10. What happens to this? I am purposefully taking it different from this case. You can take same also. We'll see. 2x minus y is equal to 0. We wish to take it as y as 10. So it is 2x plus 2x minus 10 is equal to 0, making it 2x is equal to 10, x is equal to 5. If I take y as 10, x comes down as 5. Just for inspection, just to see what happens. If I take y is equal to 20, what happens here? 2x minus y is equal to 0, 2x minus 20 is equal to 0, 2x is equal to 20, x is equal to 20 divided by 2, making it 10. So if you take y as 20, you get x as 10. So the idea is, because we started with same equation, whatever path we follow, we take it minus 2x plus y is greater than or equal to 0, or we take 2x minus y is less than or equal to 0, we end up with same line. Let me remove all this so we can just concentrate on our lines. 0, 0, 10, 20, 0, 0, 10, 20. Yes, you can take a point as 5, 10 also. Yes, you could take a 15, 30, you could take a 200, 400, any point is possible. We are taking points which are within our limits, which we can plot, because 200 would be very far off from 0. It will not be possible for me to plot on a paper unless I take a larger scale. So in any case, the idea is that whatever path I take, I am getting the same line. But it is not about plotting a line. It is about plotting an area, about plotting a region. The constraints are of less than or equal type, greater than or equal type. So equal is that line part, but less than is a region part, greater than is a region part, an area. We have greater than, less than, So when I am talking of all these constraints, these are areas, these are not lines. What I have done over here is line. Now if you check out again our other videos, you'll see that in order to reach these areas, I need to reach the boundary. Once I get to that boundary, I say that this is the greater than area, beyond this is the less than area. So in order to reach to the regions, to reach the areas, first you need to get to boundaries. So these are my boundaries. Let me see how they pan out. Let us say this is x axis and y axis. Now one point is 0, 0. Other point is x 5. Let us say we take 5 and 10, 5 and 10. So x is 5 and y is 10. This becomes my point. Now I'll leave this one for some time. We'll only talk on this constraint. So my constraint was y greater than 2x. I converted into all variables being on LHS. I took y on the other side. I'll leave it over here so that we do not get confused. I took y on the other side, making it all constraints on one, all variables on one side, but then my practice is variable should be on left hand side. So I switched them to left hand side. 2x minus y was less than, so 2x minus y was less than. Fine, and 0. We'll come down to this approach once again, but for now this is the approach. These were the points we found out. This is the line we have found out. Now I need less than area. This is my constraint. Why is this my constraint? Because my variables are on left hand side. So this is my constraint and I need to find out my area. Which area? Less than area. Now before I try to find out this area, again a recap from our previous videos. In this constraint, less than area would be and greater than would be. Why? Because area towards origin is less than. If I take some other constraint, some other shape, let's say this one, less than would be, all this is less and this is greater. Why is this less? Area towards origin. Area towards the origin of a line is the less than area. This is less than. Now this might seem to be greater than because it is on top of the constraint, but it is towards origin, so this is less than. All this is less than. Why is this less than? Because the origin is on this side. So in all these cases, it is very easy to find out our less than or greater than areas. What happens? How do we decide which is less than or greater than? We decide less than or greater than depending on the origin. Where is the origin? Wherever you have your origin, that will be the less than area. In this case, where is the origin? Actually, my line itself is lying on the origin. So how do I decide which is less than? Again, in all these, we can decide. This is less than, this is greater than. Here we have our origin, less than, greater than. Here we have our origin, less than, greater than. Very easy to decide because wherever we have our origin, that is the less than type. But here the constraint itself is passing through the origin. How do we decide? In such cases, how do we decide? We have a look at x. We have a look at x. What is the coefficient of x? If it is a positive quotient, listen very carefully. We have a look at x, the coefficient of x. If it is positive, then the greater than area is on positive side. If it is negative, then the greater than area is on the negative side. So, sign of x will decide what is greater than and which will be less than. Obviously, the opposite one. Sign of x will decide the greater than. What is sign of x? Positive. Sign of x is positive. Where do we have x? positive, this is x positive, this is x negative and y negative. So sine of y decides, or sine of x decides which is positive area. This is positive area because I have sine of x is positive, coefficient of x is positive, plus 2. So sine of x decide the larger than area, the greater than area. This is the greater than area because x is positive. Which area do you need? You need less than area. So this is the area you are concerned about. Are we clear on that? X decides the greater than area. And then you decide upon which area are you interested in. Plus 2 telling me that this is the greater than area. X is positive on this side. This is the greater than area. But I am interested in less than, so I will pick this one. Now, if still there is some confusion, let us talk of this. Let us take plus x plus y minus x and minus y. We have a 10 and 20 this time. 20, 20, 10 and 10. Now, one point will be 0, 0, which obviously is over here. Second point will be 10, 20, x 10 and y 20. Remember what was the point last time? X 5 and y 10. This was the point last time, this is the point this time. Leave this because this was from here, we are not talking of it. This becomes my constraint. Once again, I decide upon less than or greater than area depending on the placement of origin. But this time my constraint, my line itself is passing through origin. So how do I decide? Who will tell me which is the less than or greater than area? Who tells me which is less than or greater than area? Coefficient of x. Coefficient of x is negative. So for this constraint, all this will be greater than area. Coefficient of x tells me the greater than area. It was positive, so this was greater. This time it is negative, so all this is greater because x is negative on this side of the constraint. This is my constraint and all this is negative. And it will be greater than area because x is negative. But I need greater than area this time. Remember, coefficient of x tells me the greater than area. Coefficient of x is negative, so all this is greater than area. And which area am I interested in? Greater than. So what is the interest area? Same. Now look very carefully. This time it is greater than inequality. Last time it was less than inequality, but still the area is same for both. Why? Because we tried solving same question, same equation, same inequality. That is the reason why this works out like this. So we'll solve this question and then we'll see where is our interest area lying. So what is our first constraint? I need 2 points from my first constraint. Let me make it 0. If I make this as 0, x as 0, y will become 100 by 3, that is 33.33. If I make y 0, x will become 100 by 7. 100 by 7, making it 14 point 14.28. First constraint converges to these 2 points. What about second constraint? Second constraint would be, I need 2 points once again. Those 2 points would be, let me take x as 0, y becomes 80 upon 6. I'll fetch the calculator because we'll be needing calculator today. 80 divided by 6, 13.33. Then when I take y as 0, this becomes 0. So I get 4x is equal to 80, giving me x is equal to 20. This becomes my second constraint. First constraint, second constraint, and third constraint. Third constraint would give me points as this one. We checked out this constraint cannot be solved in present state. We need to convert it into some feasible state. What I'll do is, you can do anything. You can bring it over here. So let us say it becomes minus 2x plus y greater than equal to 0. I have brought this minus 2x over here, so it becomes minus 2x plus y greater than equal to 0. So this will be my third constraint instead of the previous one. This is our third constraint. How do we solve it? Make x as 0, y also comes down to 0. Put y as, let's say, 40. If I put y as 40, what if this becomes? Minus 2x plus 40 is equal to 0. Minus 2x is equal to minus 40. X is equal to minus 40 upon minus 2, making it 20. So if I put y is equal to 40, x becomes 20. So these are my three constraints and 3 points. First set of points, first point, second point to give me first constraint, first line rather. First point, second point to give me second line. First point, second point to give me third line. So for first constraint I have 2 points, for second constraint I have 2 points, for third constraint I have 2 points. Now let us get on with our graph. This is better. We have x and we have y. Now our points are ranging from 0 to 14, 13, 20 and almost 40, almost not exactly 40. So let me take an axis where I can touch 40. This will become 20, 10 and 30. So I have a 10, 20, 30 and 40. Here also let me take an axis where I can get 10, 20, 30 and 40. This giving me my origin 0. And then half of these will give me 5, 15, 25 and 35. 5, 15, 25 and 35. So what is our first constraint? x0, y 33.33. x0, y becoming 33.33. Then y0, x becoming 14.28. y0, x becoming 14.28. This is my first constraint. Can I draw a line? This is first constraint. For second constraint, we'll make use of some other color. It is 0, x0, y 13.33. x0, y is 13.33. Then y is 0, x is 20. This is our second constraint. Third constraint is both are 0. Let me make use of this. Both are 0. And then x20 and y40. x20 and y40. This point. This is our third constraint. Third constraint. So first, second and third are done. Now I need to find out my feasible area. Feasible area for first constraint. First constraint is of type less than. This is my first constraint. Less than should be this area. Why this area? Because the origin lies on this side. All this is greater than area. If I put my hand over here on this first constraint, all this is greater than area. This is less than area. So first constraint agrees to this. First constraint agrees to all these areas. Yes, first constraint agrees to second, third and fourth quadrant also, but we reject the second, third and fourth quadrant because of that physical constraint which I forgot to put over here. The physical constraint says x and y will be greater than equal to 0. So this physical constraint rejects the second, third and fourth quadrants. So these are the acceptable areas to first constraint. First constraint is this: everything on left hand side, everything towards the origin is acceptable to first because it is less than type. Then for second constraint, again less than. This is my second constraint. Everything towards origin is acceptable. Towards origin, this, this and this. If you look very carefully, these are the areas which are towards the origin of second constraint. Second constraint, these are the areas. And what about constraints of area of last constraint? Third one. Third one is not this, third one is this one. Greater than type constraint. Now how do I decide what is the greater than area? We decide greater than area according to sign of x. Sign of x is negative, so everything on negative side will be greater than area. Minus x and minus y. Sign of x is telling me the greater than area, and incidentally we are interested in greater than area only. So this is the constraint and this is the negative side. Where does the negative x lies on this constraint? This side. So all this is feasible area for third constraint. So everything on this side is this is third constraint. So it will be 3, 3, 3. Everything on this side will be feasible for third constraint. Now if I have a look over here, everything on this side is feasible. This is also feasible, this is also feasible. Technically all these are, not this one. Technically all these are feasible, but I am ignoring all these. Why am I ignoring all these? Because of this physical constraint. Because of this physical constraint, I'll plot it in a very smaller version. This is how our constraints are made. This is how our constraints are stacked up. This is less than. This one is also less than. And then this one is greater than. So this particularly is the area where all constraints are agreeing up to this. So this is the area. This is the area which we call feasible area, feasible region. Why is this the feasible region? Because 1, 2 and 3, all three are agreeing to this area. This is an area where 1, 3 are agreeing. This is an area where only 3, only 1, 2. These are the areas where only 3 is agreeing, not 1, 2. So we'll ignore all those areas. We'll take up only this area. Remember, there will be only one and only one region, quadrilateral, polygon rather. There will be only one and strictly only one polygon which will be acceptable to all constraints. In this case, it is this. So now let me find out the corner points of this. Let me name them. Let this corner point be O, A and B. How do we go from here? Point coordinates and Z. We have 0, A and B. What are these? Corner points. For O, corner points are 0, 0, and if I put 0, 0 in this, Z becomes 10 into 0 plus 6 into 0. What are the corner points for A? A is intersection of y-axis and second constraint. Y-axis and second constraint. This is my second constraint. So, y coordinate on second constraint. Y coordinate on second constraint is 13.33. We can see this was 10 and this was 13.33. So, what are the coordinates for A? Y would be 13.33 and x would be 0. Why is x 0? Because x gains values when it moves on right hand side. We have not moved on right hand side, rather we have moved just vertically. So, what will be the corresponding value of Z? 10 into 0, we are taking this coordinate A. 10 into 0 plus 6 into 13.33. 13.33 multiplied by 6, giving me 79.98. Which would actually be on almost 80, but we'll keep it at 79.98. And what about the corner points of coordinates of B? B is intersection of second constraint and third constraint. B is intersection of constraint 2 and constraint 3. So, I will solve constraint 2 and constraint 3 simultaneously to get values of B. Constraint 2, that is 4x plus 6y is equal to 80, and constraint 3, which is minus 2x plus y is equal to 0. I will solve these two constraints simultaneously to get values of B, x and y values of B. Now, if we look at these constraints very carefully, what you can do is simply multiply this to 2, which will convert them into 4x plus 6y is equal to 80. We are not touching the first constraint, but we'll multiply this with 2, making it minus 4x plus 2y is equal to 0. And now if I try to add them, x will cancel out, leaving me with 6 plus 2. 8y is equal to 80, making y is equal to 80 by 8 or 10. So, I get y as 10. Now, you can put y as 10 in either of these equations. Let us say we take this one. Minus 2x plus y is equal to 0. This is the constraint. I will put y is equal to 10. Minus 2x plus 10 is equal to 0. Minus 2x is equal to minus 10. X is equal to minus 10 upon minus 2, making it 5. This point is supposedly 5 and 10. How much will be the value of Z for this? 10 into 5 is 50. 6 into 10 would be 60. So, 50 plus 60, 110. Now, can I tell what is the value of Z max? My answer would be, the solution of this problem would be x is equal to 5, y is equal to 10 to give me a Z, which now I can say even max. These were the Z values 0, 79.98 and 110, but now I can say the max value is 110. This is solution of this data set. I had an objective function. I had 3 constraints, one of which needed some modification. So, I modified it, I plotted it, and these are my values. So, this was it for solution of or maximization of this linear problem. Hope this helps. Still, if some doubts remain, you can leave those doubts in queries. We'll try to sort them out. And thanks for watching. Bye bye. Take care.